4, 3, 2, 1. And liftoff of Space Shuttle Atlantis. A final visit to enhance the vision of Hubble.
For the first time in over 50 years, humans are going back to the moon. But here's what most people don't realise. Missions like this don't always go as planned. One small failure, one wrong calculation, one system glitch, and everything can fall apart. Hundreds of thousands of miles away from Earth, with no way to come back. This isn't a simulation. This isn't a test flight inside Earth's orbit. This is deep space. NASA is about to launch 4 astronauts on a journey that will take them farther than any human has gone in decades. But how does this actually work? How do you even go to the moon in 2026? Do astronauts just sit inside a rocket and fly straight there? Not even close. First, they are strapped inside a spacecraft mounted on top of one of the most powerful rockets ever built. That rocket launches them into space, then separates. The crew continues orbiting Earth for a short time, before performing a precise burn that sends them out of Earth's gravity entirely. From there, they travel through deep space for days, approaching the moon at incredible speed. They don't land. Instead, they swing around it, using its gravity, and begin the long journey back home. A perfect loop across space. Every second calculated, every movement planned, and if anything goes wrong during this journey, there is no quick rescue. Now here's where it gets even more interesting. This mission Artemis II is part of a much bigger plan, not just to return to the moon, but to build a future where humans can live beyond Earth. The mission is expected to launch around 2025-2026, and the entire journey will last roughly 8 to 10 days. But what happens during those days could decide the next 50 years of human space exploration. Who are the astronauts on board? What exactly will they experience out there? And why is this mission so critical before humans attempt to land on the moon again? We're about to break it all down. Let's get into space. For decades, the moon has been right there, visible almost every night, and yet no human has gone beyond low Earth orbit since 1972. Think about that. More than half a century, and humanity never went back. Not because we couldn't, but because we chose not to. The focus shifted, budgets changed, priorities moved toward Earth orbit, satellites, space stations. But now, everything is changing again. NASA's Artemis program is not just another mission, it is a full-scale return to deep space. And Artemis II is the first time since the Apollo era that humans will leave Earth's orbit and travel toward the moon again. But this mission is not about landing, it's about testing the spacecraft, testing the systems, testing the humans, because before you land on another world again, you have to make sure everything works perfectly. The journey begins on the ground at Kennedy Space Center in Florida. Standing on the launch pad is the Space Launch System, one of the most powerful rockets ever built, taller than the Statue of Liberty, generating more thrust than the Saturn V rockets that took humans to the moon in the 1960s. At the very top of this rocket sits the Orion spacecraft. This is where the astronauts will live during the mission. Inside Orion, space is tight. Every switch, every screen, every system is designed with precision, because once they leave Earth, there is no room for error. The moment of launch is unlike anything else. Engines ignite, a controlled explosion powerful enough to shake the ground for miles, and slowly, the rocket begins to rise. Within minutes, it is travelling thousands of miles per hour, breaking through the atmosphere, leaving Earth behind. Then comes the first major step, separation. The rocket boosters fall away. The core stage detaches, and Orion continues forward, now alone in space. At this point, the spacecraft enters Earth orbit, but it doesn't stay there for long. A critical maneuver is about to happen, the trans-lunar injection. This is the burn that sends the spacecraft toward the moon. It has to be perfect, too weak, and they don't reach the moon, too strong, and they miss their trajectory completely. At the exact right moment, Orion fires its engines, and just like that, it begins its journey into deep space, Over the next few days, the astronauts will travel farther than any human has in modern history. Earth slowly shrinks behind them, from a planet to a sphere, to a distant glowing dot. Silence becomes more noticeable. Space is not like the movies. There is no sound, no wind, just darkness, and the faint hum of onboard systems. Inside the spacecraft, everything matters. Oxygen levels, temperature, navigation. Every system is constantly monitored, because out here, there are no second chances. Then, the moon appears, not as a small object in the sky, but as a massive world filling the window, cratered, silent, ancient. As Orion approaches, it doesn't slow down to land. Instead, it uses the moon's gravity. This maneuver is called a lunar flyby. The spacecraft swings around the moon, using its gravitational pull to redirect its path. At its farthest point, the astronauts will be nearly 460,000 kilometers from Earth, farther than any human has ever traveled. During this phase, the spacecraft will experience the most extreme conditions of the mission. Radiation exposure increases, communication delays become more noticeable, even a simple message takes time to travel, and yet, everything must continue as planned. Because this is not just a mission, it's a test of survival in deep space. After completing the loop around the moon, Orion begins its journey back. But returning to Earth is not simple. Re-entry is one of the most dangerous parts of any space mission. As the spacecraft hits Earth's atmosphere, it will be travelling at speeds exceeding 40,000 kilometers per hour. Friction builds instantly. Temperatures outside the spacecraft can reach nearly 3,000 degrees Celsius, hot enough to melt metal. Only the heat shield stands between the astronauts and destruction. For several intense minutes, everything depends on that shield. No room for failure, no backup plan, just physics and engineering. Then slowly, the spacecraft begins to slow down. Parachutes deploy, the ocean rises beneath them, and finally, after travelling nearly 500,000 kilometers, they return home. But Artemis II is not the final goal, it's just the beginning. NASA's plan goes far beyond this mission. The next step, Artemis III, aims to land humans on the moon once again. And not just for a visit, but to stay, to build a sustainable presence, to create a gateway for future missions, including something even bigger, Mars. This mission is about proving that humanity is ready to go farther, ready to stay longer, ready to push beyond the limits we once thought were impossible. Because space has always been more than exploration. It's about survival, about expansion, about the future of our species. And somewhere in the near future, when humans stand on the moon again, they will look back at Earth, not as a place they are stuck on, but as a place they came from, and that changes everything.